So today we're going to look at integer exponents for section 6-1. So we're going to start with this power table and just look at, well, first of all, remember what a power is. A power would be, for instance, 3 to the 4th power oftentimes is what you see. So this whole entire thing here is called a power. Not just the exponent, but the entire base and exponent. So remember that this is your base, and this is your exponent. Together, that's a power. So we're going to look at these powers right now and just evaluate them. So I nicely put 5 to the 5th power here, its value. That's 5 times 5 times 5 times 5 times 5. I multiplied that out for you. It's 3,125. Then we're going to multiply 5 to the 4th power. So that's 5 times 5 times 5 times 5. The easiest way, instead of doing 5 times 5 is 25, and then 25 times 5 is 125, and 125 times 5 is, I don't know. So split the 5 to the 4th into 5 squared and 5 squared. Well, 5 squared is 25. The other 5 squared is 25. 25 times 25, you'll start to get used to, because it's a very common product, is 625. 5 to the 3rd, 5 times 5 times 5 is 125. 5 to the 2nd, 25. 5 to the 1st is 5. Let's talk about 5 to the 0. 5 to the 0 is a 0 exponent. Any non-zero number raised to the 0 power is always 1, so you want to add 0 in here. And the reason for that is this. So let's just look at 5 to the 0. How did we get 5 to the 0? So in our warm-up, we went over exponent rules with adding, subtracting, multiplying, and dividing like bases with exponents. So how would you get an exponent of 0? The only way to do that is to use division. So I must have had 5 to some exponent divided by 5 to some exponent. The only way for these exponents here to come out to be 0, because when we divide like bases we subtract their exponents, is if the exponents are identical. So you could have 5 over 5, which is 5 to the 1st divided by 5 to the 1st. You could have 5 to the 3rd divided by 5 to the 3rd. It doesn't matter so long as these exponents here are identical. And so remember, when we divide like bases, we subtract their exponents, and we like to subtract where they would be positive. Since both of these are identical values, you could subtract in the numerator or the denominator. We're going to subtract in the numerator. So we've got 3 minus 3, which is where that 5 to the 0 comes from, which is 1. And the reason why it's 1, anything divided by itself is always 1. So therefore, any number, so long as it's not 0, we'll talk about 0 being raised to itself here in a minute, but any number that's not 0 that's raised to the 0 power always has a value of 1. So 1,257,000 raised to the 0 power is 1. So this has a value here, here of 1. And then let's talk about negative exponents. So let me bring you to the definition here. So negative exponent, a non-zero number raised to a negative exponent, is equal to 1 divided by that number raised to the opposite exponent. In other words, you're going to change the sign of your exponent. So we're talking about negatives here. So for example, if I have 5 to the negative 1, as we have up there in the table, what this definition is saying is essentially this negative 1 exponent doesn't give the power of value that's negative. This negative exponent is really shorthand telling you to divide that number, put that number under 1. Essentially, we're taking a reciprocal. So we're going to take and put 5 to the 1st power under 1. And notice that that negative exponent went from negative to positive. Technically, this would work the same here. I could take 5 to the 2nd and put it under 1, and it would be 1 over 5 to the negative 2. So you can just change it to its opposite exponent. Very rarely do we change a positive exponent into a negative exponent. We always want negative exponents to become positive. So in this case, 5 to the negative 1 is equal to 1 over 5 to the first, which has a value of 1/5. So here's a value of 1/5. Then 5 to the negative 2 is the same thing. So 5 to the negative 2 is equal to 1 over 5 squared, which is 1 over 25, because 5 squared is 25. So the value here is 1 over 25. Whoops, next page apparently. All right, so let's look at example 1. The diameter for the Model A Ford piston could vary by at most 10 to the negative 3 inches. All they want you to simplify this expression. So we're going to use what we just did. 10 to the negative 3, with that negative exponent, you're going to put 10 to the third under 1. And then you're going to evaluate 10 to the third. So any power, any base 10 power, when you multiply it out, you just take 1. And since we have an exponent of 3, we're going to tack on 3 zeros and add in a comma. So it's just 1/1000th of an inch of variance. Then let's simplify negative exponents and zero exponents. So 2 to the negative 3. So just like we just did, 2 to the negative 3 means that it's 1 over 2 cubed, which is 2 cubed is 2 times 2 times 2, which is 8. So 1/8. 5 to the 0, remember anything raised to the 0 power is 1. Then in this particular problem, the base here is negative. And these look almost like identical problems. The difference between these two problems is this base here, the negative is in parentheses, so it is raised to the negative 4 power. Here, the negative is not in parentheses, it is not raised to that negative 4 power. For instance, let's see what the difference is. So here, because of the negative exponent, we're going to take the base with its exponent and put it under 1. So I've got 1 over a negative 3, and we're going to change the sign because we performed that reciprocal. So it's 1 over negative 3 to the 4th power, which means it's 1 over negative 3 times negative 3 times negative 3 times negative 3. So again, if I were you, I would multiply those two together and those two together. Negative 3 times negative 3 is 9. So that means this is 9 times 9, which is 81. So negative 3 to the negative 4th power is 1 over positive 81. Now, how is this different right here? Well, this negative is not raised to that exponent. So what it really means is we've got a negative 1 right here in front. So we got a negative 1 times 3 to the negative 4, which equals negative 1 times, now we're going to take this 3 to the negative 4 and put the power 3 to the 4th under 1. So 1 divided by 3 to the positive 4, which equals, remember 3 to the positive 4 is 81 because we just multiplied it here. And so we actually get a negative, because of the negative 1 in front, 1 over 81. So in this case, when the negative is in parentheses, we got a positive answer. And in this case, when the negative is not in parentheses, we got a negative answer. The only time these answers will be opposite signs like this is when this exponent is even. If it were an odd exponent, it's going to end up being the same sign. So think about why that is. And if you don't believe me, come see me and I'll give you some examples. I think that's it on that one. Yep, so next page. So this time we're going to evaluate expressions with zero and negative exponents. So this time we have expressions that we're going to input values for the variables. So for example number 1 here, always use substitution parentheses. So I'm replacing just the value for x, 2. So I've got something raised to the negative 1. So that x has a value of 2, I've been told. So I really have a problem that is 2 to the negative 1. So I'm going to put it under 1. So all of a sudden that exponent changes to positive because I put it under 1, I took its reciprocal, and then you have to write the actual values 1/2. Look at example 2. So this time I have something raised to the 0 power, because I'm going to put parentheses around just the a, parentheses around just the b. So for the a, I'm inputting 8, so I have 8 to the 0 power. And then for b, I'm going to input negative 2. So let's think about this. Remember what anything raised to 0 power is that has a value of 1. So 8 to the 0 power is 1 times, and then I want to write this so it has a positive exponent, so I'm putting negative 2 to the 3rd power under 1. So I get 1 over, I still have to have that negative 2 in parentheses because I want to make sure that negative gets raised to the 3rd power. So I change the sign of the exponent to positive. And then I end up with a negative 2 times negative 2 times negative 2, and then all of that times 1. And I end up with 1 over negative 8. Next set of problems. We're going to simplify expressions with 0 and negative exponents. So when you're doing these problems, I want you to view coefficients separately from their variables and their exponents. So coefficients separately from the power. So and essentially what they're asking you to do is write these expressions so that there are positive exponents. So I'm going to put 3 over y to the negative, or 3y to the negative 2 over 1. Now these can act independently from each other. The only one that has a negative exponent is the y to the negative 2. So this is the only one that's going to get moved. So I want to put it under 1, so it gets moved down into the denominator. The 3 is going to stay in the numerator. It is not raised to a negative exponent, so we want to keep it there. All right, because remember, these are being multiplied together right here, these two values. So the 3 stays in the numerator over, and that y to the negative 2 becomes y to the positive 2 in the denominator. And that's it. It's that simple. Don't make it any more difficult than it is. Then look at example 2. We have a negative 4 in the numerator and a k to the negative 4 in the denominator. Numbers can be negative. That's okay. We just don't want a negative exponent. So we're going to keep the negative 4 here. You're not going to touch it. What we are going to do is take k to the negative 4, and remember, if taking y to the negative 2 up here and putting it in the denominator is a reciprocal, then that means that I can take something from the denominator and I can move it up into the numerator and flip it in the opposite direction, and that changes the exponent sign. So for instance, this becomes the negative 4 stays upstairs, up in the numerator, and we're going to take this k to the negative 4 and move it up top into that numerator, so it becomes k to the positive 4, and since there's nothing left in the denominator, we have a value of 1 left there, which of course we don't want to write it this way. So it becomes negative 4 k to the positive 4th. So let's just talk about this one more time. So if I want to change any power's exponent from being negative to positive, just push it in the opposite direction. If it's upstairs in the numerator, push it downstairs to the denominator. If it's downstairs in the denominator, push it upstairs in the numerator. It works both directions. So then let's look at the last example, which is example 3. So this time I have 3 different powers. X to the negative 3, a to the 0, y to the 5th. They're all independent of each other. They don't have to move together. So we're only going to move this one right here because it's the only one that has a negative exponent, so it gets moved downstairs, so its exponent becomes positive. So here's my division bar. And then let's talk about a to the 0. I don't know what a is, but anything to the 0 power is 1, with the exception of if a were 0. And I know that a is not going to be 0 because we're in the denominator. So anything to the 0 power is 1. So this is going to go away right here because that equals 1. But I'm going to go ahead and just put it in here anyway, so that's 1. And then we're going to keep the y to the 5th. And then we've moved, or we're going to move this x to the negative 3 downstairs, so it becomes x to the positive 3. As soon as we move it downstairs, the exponent changed to a positive. So now we have nothing in the numerator. So anytime you have nothing in the numerator or the denominator, it always has a value of 1. So we want to put a 1 there. And then we want to just clean up the fact that we don't write this 1 here. So our final answer is 1 over, and I like to write things in alphabetical order, so I'm going to write this as x cubed, y to the 5th. And that's it.